Okay, so we just finished running this, and we saw the results, which were here, like that. We got this equation, and we got it from here. Now I saved my work, by the way, in case you want to do the same thing, just in case, just in case your machine might crash or something like that. It might be nice to save your work, and you just go to File and save a workspace, and it will run this command, which will save the workspace. And of course, you could just type this command if you wanted to. And here's the results that we got from before. Okay, now instead of running this, let's run it and assign the results to a variable. So let's try that. So I'll just capture one of the commands that I wrote, and just save that lmfit equals that. Okay, so what did we just do? Now, when we ran this function like this, we got this result. Okay, so that is what the function does. We can say that's what the function does. It produces this result. But like all functions, they have kind of two outputs. One is the output here on the screen, which is what we see, but another is an output that you can save into a variable. And that's what we did here. So you have to remember that functions in general will have two kinds of output. One is the output to the screen, and another is the output that you can save into a variable. Okay? And so now we've saved the output of this, what's called linear regression, into this variable. So you might wonder, what kind of variable is this? Like, is it a number? Did we get a number and put it in here? Maybe this is equal to 3 or something like that. Or is it a character? Maybe this is equal to, hello or something like that. Is it a character? What kind of variable is this? Numeric variable, integer, like, for example, or string variable? You might think maybe it's more likely that it's a string variable, but whatever. Actually, it's neither of those. It's what we call a list. Now, we haven't had time to study that yet, but we're going to soon. It could also be a vector, right? A vector is a type of variable. Maybe it's a vector variable. It's not a vector variable, though. Maybe it's a matrix variable. It's not a matrix variable. Maybe it's a data frame. That's a type of variable, too. But it's not that either. It's a list. Now, actually, a list is a kind of data frame, but it's more flexible, because data frames, all the number of rows in each column has to be equal. But a list, that's not true. So a list is kind of more flexible than a data frame. But it turns out that it's a list, so it's a whole lot of different stuff, basically, we can say. Okay, so now this is like a big list that's been saved into there. Now, if you just type out the variable itself, you just get exactly what we got before. However, it is a big list, and we saw before we had a data frame. Up here, empty cars was a data frame, which is actually a list, as I said. A data frame is a kind of a list. And we could run summary on it. So we can probably run summary on this to see some results for that. So let's try it. So here we get the result of this. So it tells us more, and for example, it tells us something about the so-called residuals. Now, you haven't studied regression, so you don't, unless you have, you wouldn't know what that means. But you can see that it's kind of the same kind of summary information we saw before, like the minimum and the maximum, the medium. It tells us something about the coefficients, which basically refers to something about these. These are the coefficients, negative 5.3, 37, and so on. Those are the coefficients. It tells us about those, which they're right here, but it also tells us some other information about them. It tells us this is information about how accurate the line is. And basically how accurate means how close are the dots to the line. Now the line is somewhere in here. We're going to actually see the line. But the line is somewhere in here. So how close are the dots? So that's what we mean by accurate. And these numbers tell us something about that. Basically this multiple r squared, the closer this is to 1, the more accurate it is. And the closer it is to 0, the less accurate it is. And 0.75 is pretty high. And this is pretty close to a line, really. Now we can also apply the plot function to this object that we got here. So we can do this. So we get this. And this is a kind of, now, by the way, you have to click on this screen to get it to change. As you said, it says, as you see, it says waiting to confirm page change. Now this is a kind of diagnostic screen that tells you basically how far the dots are from the line. And it's basic, well, we won't go into that now. Let's see what else. And this is again another kind of diagnostic, and another one, and another one, and that's the last one. Okay, now there's one, if you want to see the regression line, you can also run this. So let's see, I think we had run something else. Yeah, we just, okay. So you have to close this first, close what you had first, rerun the plot first, and then do this AB line and put the model that we created, the regression model we call it, or the LMFIT, put that in there and run this like that, and that will give you the regression line. Then you can see how close you can visually see how close the dots are to the line. Now typically this AB line, let's do this, question mark AB line, you can put the regression variable that we saved like this, LMFIT, but typically to plot a line you would do this, AB line, and A is the intercept and B is the slope. So let's just try that just to play with it. So I'm doing this one. So I'm using the same slope, but instead of 37 for the y-intercept, I'm using 20. So let's see how that. Okay, so that shows up there. Okay, so you can use this AB line to plot lines like that, but if you want to plot, and so we could have just copied in this number and this number, or actually vice versa, this number and then this number, to plot the line. But we can also put in the variable that we use to save into the regression, save the regression into. Now finally, if you wanted to predict miles per gallon from car weight in a new set of data, what do we mean by that? First of all, you'd use this. So you'd use the model that you, or the variable that you saved your regression results into, LMFIT, and then a new data set here. Now by a new data set, what do I mean? Well, what do I mean by if we want to predict the miles per gallon from car weight? So in other words, if I have car weight, okay, go back to here. Suppose the car weight was 3.5 tons, I guess this is. So then the prediction would be here, the height of the line here, which is over here, which is like 18 or something like that, 19 maybe. Okay, 19 miles per gallon. So if the car weight was 2, what would we predict? We'd go up to here, and we'd predict this, whatever this is, maybe 26 or something, 26 and a half or something miles per gallon. So if we wanted to, take a new set of data and make predictions, by predictions we mean putting it basically into this line. In other words, taking the weight and putting it into the line and seeing what the miles per gallon would be. So the way that you can do that is, well, what they mean is, then you would have a bunch of weights that you want to make predictions for. For example, you might say, what if the weight is 2.5 tons, and what if the weight is 3.5 tons, and what if the weight is 4.5 tons? So you might have a bunch of them that you want to make predictions on. You might just have one. So that would be your list in here. So that would be your new data. And that would take the form of a of a vector, and then you would make this prediction. Okay, and if you want to predict based on a new set of data, then you would put in your new data here and put this in here, but actually you have to run it a little bit differently, like this. So you have to do here, so you put in the model here, just like here you put in the model, but then the new data has to be, so you have to do it like this. So you have new data, which I have here, 2.5, 3.5, 4.5. I put that here, and then the name of the variable that's supposed to basically replace, so it's weight data, so it replaces the weight variable. And then I have to surround that by this data.frame. Otherwise this won't work. It won't know what to do with it. So you have to put data.frame in there, and then it will know what to do with it. It will know to treat this new data as the weight variable in your data frame. And then here, okay, with this, and then you get the result. So for if the weight was 2.5, the mileage would be this. If the weight was 3.5, the mileage would be this, and if the weight was 4.5, the mileage would be this. And these numbers are just, I guess maybe even just column markers, or maybe this is a vector. Okay. Now, if you wanted to, you could run it this way. Just like that. And what's this going to do? This is going to take the original data set, and we had, like here, we have a bunch of dots. So these all represent cars. And so like this car had this weight here, but its mileage was here. It wasn't up here, right? So what do I mean by it wasn't up here? It means this was our prediction line. This was our regression line. This is what we would use to predict. Which dot was I talking about? This one. So this dot here. So its mileage was here, but the predicted mileage is up here. So it didn't meet the predicted mileage, whatever that means, but it didn't. So, but if you want to know what the predicted would be for this car, you could run this here. So it'll tell you for each car what the predicted value is. So if you do that, you see this. So for the Mazda 4XR, the predicted is 23.28, whatever this is. and so on. So these are the predicted values as opposed to the actual values. So you can do that. But if you want to put in a new set of data, like we said, new data, which I created a new data set here, and then, or actually I created it here, then I can, if I put it into this format like this, then I can run it in the prediction function with my model to see what the predictions will be. And the predictions turn out to be these three numbers here. So this is actually getting into some data mining, but we're not getting that far. It's just an example. We're still just trying to learn to use R. But later on we'll come back to this and talk about this again and use other methods for prediction as well. Okay, so that is the end of these videos for this week. Now I'll have an assignment in one more video for this week. So don't forget to check that as well.